All right, so this is page 18 in the notes packet. So here we're kind of building on what we were doing on the previous page where we were using our graphing calculator to find the zeros, the x-intercepts by finding where the graph of the function intersected the line y equals 0. Here, what we can do is we can actually figure out when any two functions are equal. Right, so it may not be right here one of the functions was y equals 0, but we might want to have a different function and figure out where does it hit the first function, right? In other words, where are the two functions equal? And so we can do that for simple functions. We can just solve with x. So for example, if we have f of x and g of x, well, if we want to figure out when does f of x equal g of x, well, we just want to set these two functions equal to each other. We just want to say 3x minus 21 is equal to 2x plus 7. And then what we can do is we can subtract 2x from both sides. That would give us x minus 21 is equal to 7. And we can add 21 to both sides. We can see that these two functions are equal when x is equal to 28. All right. But for more complex functions, for example, if we have a cubic function and a quadratic, it will be more difficult. It will to determine where that happens just by setting the two equal to each other. So an alternative that we can use is we can use our graphing calculator. And so what we're going to do, kind of very similar to what we did yesterday, we want to put the first function in y1. So in this case, it's x cubed plus 2x minus 4. We have x cubed plus 2x, not in the, not all in the exponent, minus 2x plus 4. Okay, so there's our first function. And then our second function is negative x squared plus 12. And I did notice that the signs there were off. Should be plus 2x minus 4. And then negative x squared plus 12. It's going to be negative x squared plus 12. We can hit graph. You can see that we have our two functions and we can see the intersection of them. I might adjust my window just a hair. Right, maybe I'll make this y max 15. Maybe I'll make this x min negative 5. Yeah, that's a better window of it. All right, and now we can do, just as we were doing yesterday, the second intersect function. And we want to follow along. Where's my cursor? There it is. Follow along first function, second function, enter. You see that the intersection is at 2, 8. So that means they are equal when x equals 2. And the value of both of the functions when x equals 2 is 8. So intersect at the point 2, 8. All right, then we can do the practice down here. So all the points where the two functions are equal. So the first one is 1/2 x plus 2. We're going to do 0.5x plus 2. And the second function is negative x squared plus 5x. So negative x squared plus 5x. Let me graph it. There it is. And we see that we have two different intersection points, right? So we want to make sure that we're finding both of those. So let's start with the left one over here. Enter, enter, enter. We see that it is when x is equal to 0.5. So it's 0.5 comma 2.25, right? There's our first point. And we want to do that again. Second, intersect, go over to the right one, enter, enter, enter. You can see that that is 4, 4. So those are the 2 points where those two functions intersect.